This lecture is going to go into the fundamental ideas behind the simple linear regression model. So the regression model is basically an equation that's going to describe the relationship between y and x plus some error term. And it's going to use the format of y equals beta naught plus beta 1 times x plus e. So our parameters are going to be beta naught and beta 1, which are characteristics of our population, and then our random variable is that error term at the end, which accounts for the variability in our y that cannot be explained by the linear relationship between x and y. So going back to our Butler trucking example, the population will consist of all the driving assignments that can be made by the company. For every driving assignment in the population, there is a value of x, which are your miles traveled, and a corresponding value of y, which is travel time in hours. So typically, we don't have all of the population parameters, and so we're going to have to use sample statistics. And so our sample statistics are B naught and B1, and we treat those as computed estimates of our population parameters B naught, beta naught, and beta 1. And so that equation is going to be obtained by substituting those values into the equation. So when we're doing an estimated value, we have y hat, because that's going to be our point estimator of e of y of x, and b naught is our estimated y-intercept, and b1 is our estimated slope. So to estimate the mean or the expected value of the travel time for our driving assignments, we would find that it was 75 miles. And so Butler Trucking Company would substitute the value of 75 for x in the equation of y hat plus b naught plus b1x. And so if we're thinking about that estimation process in our simple linear regression, we want to make a regression model that describes our population parameters. But as we've discussed before, it's not always feasible to get observations from every participant within your population, and so you take sample data x1, y1 to x2, y2, and so forth. Then you use your sample data to prepare an estimated regression equation where y hat equals b naught plus b1x, with your sample statistics being b naught and b1. So then you can take the values for b naught and b1 and use them to be estimates of beta naught and beta 1 to make your overall population regression model with the unknown parameters of beta naught and beta 1. And so here are some possible regression lines in simple linear regression. The regression line in panel A shows the mean value of y has a positive relationship to x. And so we see with larger values of e of y of x associated with a larger value of x. If we look at panel B, the mean value of y is negatively related to x. So we have smaller values of e of y of x associated with larger values of x. And if we look at panel C, the mean value of y is not related to x at all. And so what we see is that e of y of x is the same for every value of x.